So far we have seen the machine learning and linear regression fundamentals. Now it is time to implement the linear regression through the program, and this will be your first machine learning program where you will be using some basic libraries to implement the linear regression for predicting a house price. So let us start with the first cell. In the first cell, we are importing some libraries. You are already familiar with the NumPy and Pandas. The third library is from the sklearn or scikit-learn. You can refer the scikit-learn from the given URL. As it is beyond the scope of this course, we will not be discussing scikit-learn in more detail. We are importing linear model from this sklearn in the third line. This linear model will be useful in creating an instance of linear regression, and then in the next line we are importing the train test split. The train test split will help us in splitting the data into train dataset and test dataset. Finally, we are importing R2 score. This is the R square score from the sklearn. So the R2 score will help us in finding out the goodness of the model. So let us start with the loading the dataset. So we will call the pd.readcsv function for reading the data from the housing.csv and storing it into the dataset. Let us display the first 10 rows of the dataset. As you can see, there are 5 columns: bedrooms, bathrooms, square foot living, floors, and price. There are 5 columns, and as you have seen earlier, we will be dividing these 5 columns into X and Y. So in the next cell, we are using the dataset.iloc for dividing the data into 2 segments. The first 4 column will be assigned to X, and the last column, which is the price, will be assigned to Y. Then we are checking for any of the not available values, and we are filling those values. You can print the values of X and Y to understand them. After dividing the data into X and Y, now it is time to split the data. So we are calling a method train test split, which will return 4 sets of information: X train, X test, Y train, and Y test. We are passing X and Y, which we have derived from the previous cell. We are setting the test size to 0.2, which is the 20% of total data, and then we are setting the random state is equal to 7. This random state will help you in picking up the random rows for training and testing. So after running this cell, you will have 4 variables: X train, X test, Y train, Y test. Now it is time to create an instance of the model. Since we are working on the linear regression, we are creating an instance of linear regression using linear model derived from scikit-learn, and we are calling it regr for the regression. So once you create the instance, now your regr refers to a linear regression model. Now it is time to train your model. So you can call the regr.fit method, and you can pass the X train and Y train values inside that. The model will learn the relationship between X and Y from the given data, that is X train and Y train, and it will have some inference from there. After that, you can test your model by providing the X test values. You have already X test and Y test, but you are not using Y test here. You are only passing X test, and you are asking the model to predict the Y value for the given X test. After having Y predict, you can check the goodness of your model by seeing the R2 score. So basically we want to check whether the model is working properly or not, and for that we are comparing the values which are available with us, which are the true values. We call them Y test, and the Y which is predicted by the model for the X test. So you can pass Y test and Y predict for the R2 score, and it will give you some value which is a score, which is R square score, and as you can see it's around 0.499. This indicates that your model is doing good, but it's not the best, because if you get the score near to 1, then your model is fitted the best. If it is less than 0 or very close to 0, then it's not doing well. But the results which we are getting are not very discouraging. We have 0.5, which is good for the first program. Now it's time to see the model in action. Now in this cell, we will ask the user to enter some dummy values, and whatever the values user will enter, based on that the model will predict a new price for the given value. We need 4 parameters: bedrooms, bathrooms, living space in square feet, and number of floors. So once you run this cell, the program will prompt you to enter the values. So let us enter the values for bedrooms. I say I have a house with 4 bedrooms, 2 bathrooms, and the space is around 1850 square feet, and it has only one floor. And tell me what would be the price for this type of house. So it has predicted a value for me, and it says that the house having this type of features or this type of facilities can be sold for the price 4,29,837.40. Remember that our model accuracy is around 50%, so we are not very confident, but it's not very bad also. So congratulations, you have executed your first machine learning program, and now you can use the similar logic for predicting values for different situation and for different data sets.